This video accompanies learning IoT with Python and Raspberry Pi. In this video, you will be introduced to the list type. For the final example, you'll need either the SenseHat device or use the SenseHat emulator. The list is a sequence type, often used to store related data. The list type is mutable, which means that the values stored in a list can be modified. For instance, it might be used to store a sequence of temperature measurements, a sequence of pressure measurements, etc. Three of the ways a list can be created are shown here. Square brackets are used to delimit the sequence of data to be stored in a list. The first assignment statement results in an empty list being assigned to the variable the list. In order to make their code more readable, programmers will sometimes use names that end in list to indicate the data type of the object. However, this practice is not universal. The second assignment statement also results in an empty list being assigned to the variable the list, but this time the list constructor is used. The third assignment statement shows the syntax of an assignment statement that assigns a list of values to the variable the list. Because lists are mutable, elements may be added to, modified, or removed from a list. A list can contain either immutable or mutable data types. For instance, a list might contain a sequence of immutable types, such as floats, ints, or strings, or it might contain mutable types, such as lists, and this would essentially be a list of lists. A list can be created by a square bracket enclosed, comma-separated sequence of values. In the first assignment statement, 4 barometric readings are assigned to the variable plist. Each of the 4 elements is of the float type. One of the features that makes a list type so powerful is that the elements of a list do not need to be all of the same type. In the second assignment statement, a list containing a float, a string, and an int is assigned to the variable Everglades. In the third assignment statement, 2 lists compose a list assigned to the variable LOL. We won't discuss lists of lists any further in this video lecture. Lists are indexable, which means that an element can be accessed by index. The syntax is the name of the list, followed by square brackets that enclose the index. The first element in a list has index 0, the second element has index 1, and so on. The final element in a list has index 1 less than the length of the list. An index is an integer, and valid values for a particular list range from 0 to 1 less than the length of the list. Let's consider again plist, which contains 4 elements. The print function call prints out the 4 elements. The for loop is a convenient way to iterate through a list. This for statement is written to iterate through the indices of plist. We use the range function, and by passing it the length of plist as the argument, a sequence of integers that ranges from 0 to 1 less than the length of plist will be returned. We'll write a script in which for loops are used to iterate over plist. The first for statement is written to iterate over a sequence of integers corresponding to the indices of plist. Each iteration of the loop, the element is printed out. A for statement can also be written to iterate over the elements of the list itself without reference to the indices. We'll save the script. And run it. The elements of a list may also be accessed by indices that are negative. The index -1 corresponds to the last element in the list. Using an index that lies out of the range of valid indices raises an index error for the element does not exist. We'll save a copy of this script with a new name. This new script will prompt the user to enter an index corresponding to a particular element, and then we'll print out the user's choice. We'll call the input function, convert the returned string to an int type, and assign it to index. We'll save the script and run it. We'll enter 0. And next we'll enter -1. And you see this corresponds to the final element in the list. So the indices 3 and -1 reference the same element. The indices 2 and -2 reference the same element. The indices 1 and -3 reference the same element. And finally, the indices -4 and 0 reference the same element. If we enter an index that lies outside of this range, say -8 for instance, then an index error will be raised because the element to which that index refers does not exist. We can handle this runtime error more gracefully by placing the print function call inside of a try-except statement that handles the index error. So instead of a traceback being printed out, we'll just print out the message invalid index. We'll save the code and run it, and this time when we enter -8, the message invalid index is printed out. An element in a list can be modified by assigning that element a new value. The syntax is given by the name of the list, followed by square brackets, which enclose the index, followed by the equal sign, followed by the new value. The pressures in plist are given in millibars, but suppose we wish to convert each pressure to atmospheres. Now 1 atmosphere is equal to 1013.25 millibars. We'll save the for list example script as for list atmosphere example. We'll use a for loop, and each iteration will divide the pressure by 1013.25. We'll add an extra print function call, and we'll add a second for statement that iterates over the indices of plist. And here we'll use an assignment statement to divide the element by 1013.25. And we'll print out the element as well. We'll save the script and run it. The first list is of pressures in millibars, and the second is in atmospheres. In the previous examples, the values of the elements contained in the list were known when the script was written. This will usually not be the case. In order to create a list of a particular size without having to know the values of the elements in advance, a one-element list that has some value, such as 0 or none, is multiplied by the size the list is to have. We'll write a script that reads in the pressure 5 times from the senshat. We'll import the sleep function from the time module and the senshat class from the senshat package. We'll assign an instance of the senshat class to the variable sense, and we'll assign 5, which is the number of pressure readings, to NP. Since the pressures have not yet been read in, we'll create a list that has 5 elements, each initially having the value 0.0. We'll print plist out so that you can see each of the elements has value 0 when the script runs. And we'll call the getPressure method once because recall that this method returns a value of 0 the first time it's called. We'll use a for loop that iterates from 0 to 4. Each iteration of the loop, the script will sleep for 1 second, and then the pressure is assigned to an element of plist. After the for loop, plist is again printed out, and this time it will contain the pressures read in from the senshat. We'll save the script. And run it. plist has been initialized to 0. And now the pressures have been read in. When writing a script, a programmer often will not know how many elements a list should have. The list class provides methods, among others, for appending and removing elements. We'll explore these in another video. Go to www.learningiot.net for more information on where you can buy Learning IoT with Python and Raspberry Pi.